Welcome to what should be an awesome, action-packed workshop. In this workshop, we're going to be talking about a critical security control in the cloud, private endpoints, and how they can be exploited by attackers to do some of the most nefarious attacks that are out there. This content is based on my course, Sec 510, Cloud Security Controls and Mitigations. More on that later. So we're going to start off by talking about why private endpoints are such an effective security control. We're then going to talk about how attackers can leverage them in their attacks, how they utilize supply chain attacks in order to accomplish this, and then we're going to get into our workshop. 15 minutes before the workshop concludes, we are going to do a quick debrief of what we learned, and then I'll leave you with some additional resources and QA. So let's first start off by talking about why private endpoints are such an effective security control. So before we do that, we have to understand the cloud networking capabilities that we have for our infrastructure as a service offerings. You might be familiar with virtual networking, how AWS and GCP call both of these things VPCs, and how Azure calls them VNets, but that these are mechanisms that you can use to logically isolate your cloud infrastructure. By that, I mean servers, containers, functions, any of your compute services or your databases on things like the relational database service or RDS. So that's great for taking your infrastructure off of the public internet. However, not all of the data that you store in the cloud is in your own infrastructure. In fact, the majority of your data is not in your cloud infrastructure. Instead, a lot of this data is stored in cloud resources that are a part of the platform as a service offerings, or PaaS. Now, examples of this is the simple storage service or DynamoDB, and you do not have the ability to take the services that are used for platform as a service and take them off of the public internet. You can't put S3 behind the firewall because then no one else would be able to access the S3 service. And that's not very nice. Other people have to use this service too. So how can we get the best of both worlds, where we're able to use these awesome managed services but prevent attackers from being able to exploit these well-known endpoints to access our data? Well, unfortunately, these platform as a service offerings have well-known APIs, which makes it kind of hard for you because all the attackers know how to use S3 in the same way that you know how to use S3. Now, you could leverage things like audit logs in order to find out when people are accessing your private data. However, prevention is better if possible. An ounce of prevention is worth more than a pound of cure. So how can we prevent attackers from accessing our private resources that are stored in platform as a service solutions using networking controls? Well, before we could see that, let's first take a look at what our normal flow looks like. When we have a workflow, or workload, I should say, in our compute resource, such as an EC2 instance, it is going to reach out to our platform as a service offerings like S3 or the secrets manager over the internet using a public endpoint. Alternatively, we could create what's called a VPC endpoint, or more generally, a private endpoint. And that will allow for us to connect to these platform as a service offerings using a completely private endpoint, which is stored behind the firewall. This has many advantages. The first advantage is that you can continue to use these services like S3 or DynamoDB in a arguably completely isolated network. You could make it so that you can still access S3 with zero ingress, zero egress, no internet gateway, no NAT gateway, which is nice because now you can limit the access to the actual workload. Now, that's great, but I think even more valuable is the ability to create policies that control access to these cloud resources unless the traffic originates from your private network. We can say, I don't care if S3 is public, you can't access my S3 resources unless you're originating from my network. And here's what that looks like. We have a private endpoint. Our EC2 instance is going to route through that private endpoint to S3. And this works because our EC2 instance is on AWS and S3 is on AWS. So using a private endpoint, AWS knows how to route our traffic internally to our platform as a service offering using what's called the backbone network. No internet access is required. Setting this up in Terraform looks something like this. We are going to create a private endpoint for our secrets manager. And line 15 is particularly beautiful. You might think that you need to rewrite your workload in order to point to the private endpoint instead of the public endpoint. But that's actually not the case. Using the configuration on line 15, we can make it so that whenever we query the secrets manager DNS entry, it will route us to the private endpoint if we are originating from our VPC, and it will route us to the public endpoint if we are coming from the outside world. So no application rewrite is necessary. Now, here's the most powerful part of this. We can now create a policy that says that you are only able to access the secrets manager if you are coming from a particular hard-coded VPC ID, or using the technique that was introduced in March of 2023, we can simply say you are only able to access the secret if you are coming from the same VPC as the EC2 instance that is being used to get the secret. Now, we're going to talk a lot more about these kinds of policies in Sec 510, but I want to very briefly mention that it may be better to use a resource-based policy instead of an identity-based policy. And the reason why that is because the identity-based policy can result in an inconsistent, hi Lara, I think you're off mute, can result in an inconsistent perimeter such that a identity can have a different set of policies. I can give person A the ability to access this resource if only they are originating from the network, but I could give person B the ability to access this resource unconditionally. So depending on who you are, you would have different access from different networks. So it might be better to have a resource-based policy that explicitly denies access to everyone from outside of our private endpoint. Once we set this up, we will see that if we use stolen credentials, credentials that are lifted from the EC2 instance, we would find that they are unusable. They are not possible to be used outside of our private network. So that's great, but now let's talk about how these resources can be abused. Now, I want to give credit where credit is due. This workshop would not exist if it weren't for the great research from Jonathan Adler and his great presentation from the CloudSec Next conference that SANS runs annually from a few years back. So what did Jonathan Adler cover? Well, he highlighted how in AWS, we have what is called an endpoint policy. And the endpoint policy determines what traffic is going to be forwarded by the private endpoint. You'll see that the default endpoint policy allows everything. Now, that doesn't mean that the IAM service is going to allow for every action to be performed by every resource, every principal on every resource. That's not what this means. What this means is that any request made to the private endpoint will be forwarded to our platform as a service, and then the actual IAM policies will be evaluated. The reason why this is problematic is it is possible to use a private endpoint to communicate with an attacker's account. Let's say you have an EC2 instance that has access to the secrets manager. Well, the EC2 instance in this particular case has no internet access. It's in a completely isolated network. So it accesses the secrets manager over a private endpoint. Well, it turns out an attacker, if they accomplish a pretty technical attack, they can reuse your VPC endpoint to send data from their EC2 instance to the secrets manager in the attacker's account. They can leverage your endpoint to exfiltrate data to their account. And this works because the private endpoint will redirect any traffic. It'll forward any traffic that is meant to go to the secrets manager, whether it's a secrets manager for a resource in your account or a resource in the attacker's account. There's actually a pretty easy solution to this problem, but very few people know to use it. And the solution is going to be that we restrict access from our private endpoint to resources so that you can only use the private endpoint to access resources in our own AWS account and no other AWS account. So now let's introduce supply chain attacks. One second. Excuse me, still getting over a cold. So let's talk a little bit about supply chain attacks and how they can be leveraged to exploit these private endpoints. Supply chain attacks are my favorite subject in application security. If you're responsible for security, you need to care about supply chain attacks. It is the #1 thing keeping me up at night, because statistics show that 90% of all of the code that your organization ships was not written by your organization. I'll repeat, 90% of the code your organization ships was written by either strangers on the internet or people working for companies that we are trusting without really thinking about it critically. And not only is this whole applications, not only are we using whole applications from strangers on the internet, but we're also using software packages to build our own applications. Now, here's an example of a supply chain attack that would result in remote code execution. We have a server that's running in our cloud environment, and the server has the ability to access the internet. So it is going to pull a malicious package from the internet, and we'll give you an example of this in a moment. And this malicious package is going to pull arbitrary code from some resource like pastebin.com. And the beauty of using pastebin.com is that the attacker can change the behavior of this package with time. Whenever they change the pastebin paste, the application will execute in a different way. And using this arbitrary code, they could exfiltrate data to a resource like webhook.site, which is going to capture all of the requests made to it and allow you to see what data was exfiltrated. A great example of this was the ESLint compromise in July of 2018. This was an instance where a very simple library was compromised in a very significant way. This very simple library, all it did was it made it so that you could check to see if your code was nice looking, to see if your code was basically pretty. And someone inserted some malware that pulled down arbitrary code from pastebin.com. And the version of the pastebin.com paste that we can find shows that this malware was used to steal NPM tokens, which are tokens that are used to publish more packages. So this was kind of like a worm where one package would result in infecting other packages. Now, NPM took action in order to resolve this by revoking all NPM tokens that were generated prior to that time, which was great for security and terrible for Brandon, the developer, because all of our pipelines broke because these tokens were no longer valid. But we don't want to depend on NPM. We want to make sure that we don't have supply chain attacks in our environment, or at least that we can't exfiltrate data from our environment using these supply chain attacks. There were a couple other examples of this that happened in Q4 of 2021 that you could read up on here. But one of the things I really want to highlight is that I wish NPM required multi-factor authentication for publishing these packages, because these packages hadn't been developed for 5 years. NPM should have said, hey, you're trying to publish a package to a repository that hasn't been touched in 5 years. you better prove who you are. So that brings us to our workshop. In this workshop, we are going to use two different AWS accounts. One that is used by the company we're trying to protect, Aviata, and another account that is used by the attackers. And what we're going to do is we're going to show how one account can exfiltrate data to another account without any internet whatsoever. Now, you don't have to create both AWS accounts right now if you haven't already. The first half of the workshop will use a single AWS account, but in the second half, we are going to show you how you can exfiltrate data from one account to the other. Our first account will be set up using Terraform, so there's very little setup that you have to do. You're going to make some manual changes in that account, and then you're going to play the role as the attacker and use this account to exfiltrate data, both with private endpoints and without private endpoints, and then you're going to lock things down using a proper endpoint policy. The more advanced workflow that we're going to see in this workshop is we're going to have, instead of our server directly downloading packages from NPM, we're going to have a continuous integration or continuous deployment service that is going to download this package and use something like Terraform, like we're going to use, in order to provision a server that has this malicious package in it. But the server itself is going to be running in an isolated environment with no ingress or egress traffic allowed. However, you will see how we can still use a private endpoint for Amazon S3 in order to download arbitrary code from a public S3 bucket that the attacker controls. Then this arbitrary code can be used to exfiltrate data by requesting the S3 bucket and having some sensitive data in that request, at which point the attacker's bucket is going to write a sensitive log to AWS CloudTrail. So I think you're going to really enjoy this workshop. It's probably a little bit too long to complete in the next 2 hours, which we are going to have actually a little bit less. We're going to have an hour and a half. But I'd recommend getting started on it. This workshop will be available indefinitely, so you can continue it at a later time. We are here to support you on the Cloud Security Discord, the SANS Cloud Security Discord, so please feel free to drop any questions that you have there. But we're going to have an awesome workshop. You can start by navigating to www.aviata.cloud. Make sure to include that www. And I'm going to join you in an hour and a half at 12:45 Eastern, 11:45 Central, and we're going to do a quick debrief. So I hope you enjoy. I really think you're going to find this to be extremely informative, and I hope that you'll learn by doing, because learning by doing is the most effective way of learning, and you're going to have so much fun in the process. So enjoy. Let us know if you have any questions, and I will see you shortly. All right, I hope you enjoyed the exercise so far. And as mentioned before, if you did not complete it already, this is going to be available indefinitely, so feel free to complete it at a later time. So let's do a very quick debrief of what we covered throughout this workshop. Instead of reinventing the wheel, I'm just going to go back to some relevant slides. So the first thing that we did was we performed this arbitrary code execution in the Aviata environment by using a supply chain attack. So we had a package that we originally published on NPM for demonstration purposes, but they ended up taking down our demonstration package, so good on NPM. So we had the package bundled into the application that you used for uploading your medical documents. So every time you uploaded a medical document, which in this case was done using an AWS Lambda, which is their serverless solution, it would execute this arbitrary code, and it would use the pastebin paste that you pointed to execute. And in this particular case, we configured this pastebin.com to take the credentials from the Lambda, the IAM credentials used to access other resources, and exfiltrate them using webhook.site. Now, using those credentials, we were able to access S3, or at least we would be able to access S3 if we so desired. But for the sake of the workshop, we didn't really go too far in that regard. So in the second part, we moved our environment, we moved our Lambda into an isolated VPC network. And we applied a policy similar to this one to say that if you try to access S3, but you do so using the public endpoint instead of the private endpoint, we will block you. You must go through the private endpoint. So that both allowed us to secure our data in our platform as a service offering, and the endpoint also allowed us to continue to access S3, even though the Lambda had zero ingress or egress traffic to the internet. But then we had an endpoint policy that was wide open. So it allowed for us to forward any request that we wanted through the endpoint to potentially an attacker's controlled infrastructure. And that led us to this more advanced technique that we pulled off, where we actually took the S3 endpoint and we used that S3 endpoint to download an object from a public S3 bucket that the attacker controlled. So the attacker uploaded arbitrary code and uploaded it to a S3 bucket that was public that they controlled. And they used the S3 bucket as a placeholder for pastebin.com. The Lambda no longer has access to pastebin.com, but they do have access to any arbitrary S3 bucket so long as the bucket accepts the request. And therefore, we were able to download arbitrary code in that way. So because the bucket is public, that meant that we would be able to download any object from the bucket that we'd like. However, it is not possible to anonymously write a file to the attacker's bucket. As far as I can tell, there's no way to make a bucket world writable. You can make it world readable, but you cannot make it world writable. However, in this case, it really doesn't matter because we made the malicious payload that we downloaded from S3 upload, in quotes, a file to another bucket in the attacker's account. Actually, in this case, we use the same bucket, but it could have been a different bucket. And because the request failed, the file wouldn't upload. However, we would get an error log in our CloudTrail logs. So we could find the malicious data in our error logs. The attacker is going to reject the request. However, there's going to be a generated log that the attacker can read. And this would allow for arbitrary data exfiltration without any internet. RCE without internet, data exfiltration without internet. I hope you can take a moment to realize how significant this is. But at the end of the lab, the workshop, we applied a better policy in order to ensure that the endpoint would never forward any requests that were for any other AWS account. We would only allow this endpoint to access resources within the same AWS account, which makes it impossible for this endpoint to be used to access the attacker's account and use that for data exfiltration purposes and for malicious payload downloading purposes. So with that, I'm going to leave you with a couple of additional resources. So there's a lot of great resources on sans.org/cloud, but in particular, I want to once again highlight the CloudSec Next webcast that really inspired this workshop from Jonathan Adler. I strongly recommend checking that out. We also have the Cloud Ace podcast, which has people from SANS interviewing a variety of different experts in cloud security that you might find interesting. We have several ebooks from the past few SANS Cloud Exchange events, which is an event where we get together with AWS, Azure, and Google Cloud to talk about cloud security trends. And in the first ebook, I talked extensively about supply chain attacks. So if you want to learn more about that, definitely check that out. You should also check out the Secure Service Configuration in AWS, Azure, and GCP poster. We published this as a complimentary, both complimentary meaning free and complementary meaning it goes together, resource with Sec 510. So it shows all of the summaries of the differences between the cloud services in the big three cloud providers, as well as how to lock them down at a high level. We also have the multi-cloud command line cheat sheet, which teaches you how to create commands that interface with the various cloud environments. We mostly use the console for this particular environment, for this particular workshop. We use the user interface, but if you wanted to learn how to use the command line, I think that's going to be a great resource for you, as well as we have a couple other resources that are related to this workshop shown below. That brings me to a very quick sales pitch for my course, Sec 510 Cloud Security Controls and Mitigations. If you liked this workshop, you're going to love Sec 510. Sec 510 teaches you how to prevent incidents from becoming breaches using controls that matter and controls that do not require you to learn how to create application code. In this workshop, you did not fix the supply chain attack, but you leveraged cloud controls to mitigate the impact of the supply chain attack. So if you want to learn more about these mitigation strategies, and there are many of them, you should really take a look at Sec 510, Cloud Security Controls and Mitigations. And there is a free demo you can take by going to sans.org/sec510, click on the course demo button, sign in with your SANS account, and you get a free hour of the course. And that is true for any SANS course. This is one of the worst disseminated secrets, open secrets out there. You can take a free hour demo of any and every SANS class by going to that course webpage and clicking the course demo button. So please make sure to do that for Sec 510, but also consider doing that for other great classes here at SANS in both SANS Cloud Security and the broader SANS curriculums. We're going to be teaching Sec 510 in a variety of different places. I am so happy to be going to Munich, Germany in just 2 weeks, in which I'll be teaching the course. I'll also be teaching it both in person and live online, where you could take the course from the comfort of your home during Mountain Time from June 17th to the 21st, and in person in Denver, Colorado. And finally, if you want to take the course at your own pace, you can do so on demand, where you're able to watch the course at your own pace, watch a studio recording of yours truly, and learn about these cloud controls and mitigations. I'm honored to have a lot of great reviews for the course. Here are 3 of those reviews that I'm very proud to have earned. And one other review that I did not include in this is one individual said that if you cloud, you must take this course, period. So I hope that you'll consider taking the course if the budget is there. If not, I hope that you'll take a look at it at a future year, and definitely check out that course demo regardless of where you're at, because it's completely free and I want you to get as much of that content as you possibly can. And with that, we've got 5 minutes for questions and answers. Are there any questions about what we covered today, as well as the exercises? Any questions at all? You can ask that either in the Q&A on Zoom, or you can ask it on the Discord. I'm going to answer it either way you send it. All right, it looks like there may not be any questions today. However, if you have any questions for me, feel free to reach out to me on LinkedIn. Just search Brandon Evans and SANS and you should find me, or you can email me at bevans@sans.org. Or you can message me on the Cloud Discord. I'm happy to talk to you at any time about what's covered in this workshop and beyond. And make sure to fill out that very quick survey that Hayes posted on the Discord, as well as on the Zoom channel. Before that, actually, Aaron just added a question. Thank you for that, Aaron. He said, best advice to those who are just starting out in the cloud. My answer to this is the same answer that I have for most technologies. It's you have to get your hands dirty. You have to play around with the cloud environments, because reading the documentation and watching videos alone is not going to solve the problem. It's not going to teach you what you really have to know. And that's why I'm so proud to put on workshops like these, as well as why I'm so happy that Sec 510 has 20, and I think actually more, including the bonus challenges, fully fledged labs that you can perform in order to get your hands dirty. I wish there was an easier way to get started, but simply put, you will learn so much more by doing than just listening. And that's why SANS training is so hands-on and practical, and why our workshops are so hands-on and practical. But also feel free to follow me on LinkedIn. I like to post a lot of different resources, both for beginners and more advanced people. So following people here at SANS or in the larger cloud security community, or just in the larger cloud community in general, would be useful for gathering some resources on the subject as well. Any other questions? If not, please do fill out the evaluation form that Hayes posted. And I want to remind you that this is simply chapter 2 of a years-long workshop series. We had chapter 1 with Moses Frost on offensive security, which you can do at any time, just like this one, as well as we're going to have a workshop every single month, completely free, covering the various different topics that we cover in the SANS cloud curriculum. That includes detection, includes forensics, leadership skills, all sorts of skills that you need to know to become a well-rounded cloud security professional. So I hope that you'll check out the other workshops in the series. I hope that you'll reach out to me if you have any questions about the workshop series, this workshop, or Sec 510 on LinkedIn. And I hope that you have a wonderful rest of your day and week. Take care, folks.